That should be special like that.
It's a large scale film, and the music needs to have a feeling of emotion and epicness. I think that certainly was at the core of Titanic, and is very much at the core of this movie.
And it was important that James's score evoked that sense of music belonging as part of the culture.
So there are two scores running simultaneously. It's just one score represents the novelty world of sound, and then there's a traditional score on top of that to drive the film. The story is so original and really beautiful and epic.
One of the things that I'm always going to take with me is the fact that I was a part of a revolutionary experience in Hollywood.
Once you see this video, goes, you are lost in the world on the screen.
We were always trying to push the envelope. This time we were trying to push the envelope, and it pushed back, and then we pushed hard, and it took a long time because it doesn't look like anything we've seen before.
Really?
Michelle, she wanted to learn how to
She takes care of classes back and forth, 11, 12 hours, and we have Kevin, who actually taught James how to fly his helicopter, flying it up in a drone. We went to Hawaii because Jim wanted us to experience a real rainforest, just to get a physical taste of what it's going to be like to live in a planet and not have to rely on anything.
We drove away from the difference between being out in the real world and trying to and I didn't want the actors to not have any kind of basis for feeling like you don't have your foot away if you're just standing on cement. So your body reacts to other things once you've actually gone out and done those things. So it was about making it real. The focus for us was to make everything that you can't do better. So basically, if it doesn't exist in the real world, 2/3 of the movie will be done digitally. A lot of the live action component will still have some digital pieces added to it.
Tim is able to push that to break down the conditions of standard visual effects where everything can be perfect and to make something imperfect. And that's what makes it cinematic.
Incredible scope of what we're doing because we're creating on an unprecedented scale. This is going to another planet and living life on the planet and seeing what it would be like to be in these forests and advanced people. There's so many pieces that have to come together. A lot of the pieces individually would have been possible to do over the last several years. But to integrate everything into something this fast with this scope takes a whole nother level of thinking about how you're going to pull that off and what you really need to do to make it work. We just sit there and nail it with our eyes wide saying, I can't believe this. This is incredible. I've never seen anything like this.
Can go up to the visual the visuals alone cannot do it. Sound design has to be the complement.
Working with Jim, he always focused on telling story, and all aspects of the film come to play there, and sound is a big component of that. More from film, creating sounds, building a library for the editors to type a picture with, recording raw sounds, and with those sounds, creating new sounds, so that while the sound that we've created may have originated from an animal or a helicopter or a jet fighter plane, we manipulate it in such a way that it becomes something unique to Avatar. This film is so saturated with colors and things floating in the sky that you've never seen before. It just gives license to use sound in such a way that bring this world to life and help tell the story by doing so.
This movie is a immensely large scale film. And the music needs to have a feeling of emotion and epicness. I think that film is at the core of Titanic and is very much the core of this movie.
It was important that James' score evoke that sense of music belonging as part of the culture.
So the two scores running simultaneously. If just one score represents the novel worlds of sound, and then there's a traditional score on top of that to drive the film.
The story is so original and really beautiful and epic.
One of the things that I'm always going to take with me is the fact that I was a part of a revolutionary experience in Hollywood.
Once you see the three, or you what, you lost the love of screening. We're always trying to push the envelope. This time we're trying to push the envelope. They pushed back, and then we pushed hard, and it took a long time. Because it doesn't look like anything we see. It's going to be a groundbreaking movie. I just had everybody's attention for a second. This is kind of a pitching moment to make this work.
Frankly, it's thrilling to be working with Jamie Dean, to be in the first movie I wanted to do since
It's a dream project. The scripts are the first draft of 12 years ago. We start off with that because frankly, it's called holding on man. We knew that we were about to do it. So we need to be beyond it's cool. And that's where I'll be. I just want to take this opportunity to thank everybody for what it's taken to get to this moment. So thanks
Terminator.
This.
True lives. That's for the maximum. It's pushing in all this thing, and things that never was done. And all the characters and all the actions and settings. Turn out
Through a series of circumstances, he meets material. There's something about this avatar that absolutely captures your attention.
He gets dropped into this situation, and I've just added a catalyst. Something's going to change.
No, get paid now. Yes, Jake.
We were training.
Except for if you count like Haley, the most we get 35. When is the Easter break is week after next week. Yes.
Costume design for the world of Avatar.
Well, I'm surprised, Gabe, that you didn't talk them into having me.
I was trying to get it. Yeah, we're running out of water, drinks. So you don't know the password. Well,
he knows the password.
I know. We're going to know it, so I'm going to pretend. This is we're going to be formal, so don't worry. This is all about this now.
It's really big. Looks like King Kong.
So every bit of the physicality of her character, and this applies to the other non-evil avatars, everything had to be created by that.
It's very important for us to put all of our actors through a training regimen that is specific to their characters. We have them work with archery experts. We have them learn to ride horses.
To say we did a lot of training is an understatement.
I was going to do a film where I was physically talented, not only mentally. I wanted to incorporate my body to a character.
We also had to do a dialect training and a language training.
I am the creator of the Nepali language. It is between
To me, it's been the most challenging thing.
Sam had to go through very collapsed but intense Marine Corps training.
We changed Sam and teach him how to know the one thing done, showed him what's like more done. We would teach him how to computer stick, do it.
It was more right who's got to see the world. And the way they're training is to make a mistake. Nothing can stop.
You get some hard, you can't show up in this neighborhood.
It's just another element. Live action photos. We did more written training, what training?
More action. Carries this laser sighted pistol. and this comes into play occasionally.
To make it look like any do what activity is. So Michelle, she wanted to learn to fly that helicopter as if it were real.
She takes care of the science. That was an idea about employed 11, 12 hours a week, Ken, who actually taught James how to fly his helicopter, flying in a Pandora.
And we went to Hawaii because Jim wanted us to experience a real rainforest.
Just to get a physical taste of what it's going to be like to live in a planet and not to rely on anything.
You absorb everything. There's a difference between being out in the real world and coming into this incredible physical world. And I didn't want the actors to not have any kind of basis for feeling like they were in a rainforest. So we were way up in the mountains.
You remember your foot lands in mud if you're just standing on cement. So your body reacts differently to things once you've actually gone out and done those things.
So it was about making it real.
The focus for us as education is to make everything that you can't do practically. So basically, if it doesn't exist in the real world, we'll make it here. 2/3 of the movie will be done digitally. A lot of the live action here will still have some digital pieces added to it.
Here is able to push that to break down the traditions of standard visual effects where everything can be perfect, and to make something imperfect, and that's what makes it cinematic.
Incredible scope of what we're doing because we're creating a new unprecedented scale. This is going to another planet and living life on the planet and seeing what it would be like to be in this forest and these people. There's so many pieces that have to come together. A lot of the pieces individually would have been possible to do over the last 7 years. But to integrate everything into something that's benefit the scope, it's a whole other level of thinking about how you prepare that life and what you really want to do to make it work.
And we just sit there in dailies with our eyes wide saying, like, that's unbelievable. This is incredible. I've never seen anything like this.
If Pandora is to be a believable and be equal, the visuals alone cannot do it. Sound is a part, has to be the complement.
Working with Jim, he always focused on telling story, and all aspects of the film come to play there, and sound is a big component of that. Creating sound, building a library for the editor to type a picture with, recording raw sounds, and with those sounds, creating new sounds so that while the sound that we've created may have originated from an animal or a helicopter or a jet fighter plane, we manipulate it in such a way that it becomes something unique to Avatar. This jungle is so saturated with colors and things floating in the sky that you've never seen before. It just gives license to use sound in such a way to bring this world to life and help tell the story by doing so.
This movie is a tremendously large scale film, and the music needs to have a feeling of emotion and epicness. I think that's certainly at the core of Titanic, and very much at the core of this movie.
And it was important that James's story evoked that sense of music belonging as part of the culture.
So there are two scores running simultaneously. Just one score represents the non-beware sound, and there's a traditional score on top of that to drive the film.
This one is live, right? It's live right now on YouTube.
The story is so original and really beautiful.
One of the things that I'm always going to take with me is the fact that I was a part of a revolutionary experience.
Which is I'm always trying to push it. This time we're trying to push the envelope. It pushed back. I know we pushed hard. And it took a long time. Because it doesn't look like anything we've seen.
Yes, Gabe, I have to make a new thing.
I didn't know if you were working with Jim, it's going to be a kind of big technology. Years ago, we didn't start with
No.
To this
And a lot of countries really pay attention to
all the characters and creatures and stuff.
you can see right there, we have sculptures, new laptops, we have so this is all presentation. They're really technology. But the big one is like Chris Gerrard, talking about technology.
Right.
We have 3D visualize, good cameras. 5 years, 9 months, 22 days.
Jim's on a really interesting journey. Check the movie. And he gets given up to the Pandora.
your genome session of theirs could set up a ship.
And it's out of the monkey control book, which is the island used together. You place things in the rest. And like forth and put the orange shadows
We come to read in an avatar body. That's a little bit.
Thanks for coming here, everybody. I want to thank, especially the production people, Eric Starr from Shaw Studio, to Autodesk people, Ivan, and all the industry people from Hong Kong. It's really amazing for us because even for me, I'm very new to Hong Kong. And my vision is to not just stay in the classroom, but really get industry people to work with us. Like last week, we got the developer of ZBrush that comes into Hong Kong and gives us a tutorial, 3 hours straight out. The developer of ZBrush gave us from inside everything that's going to do from now to onwards. And now it becomes so close that if you want to collaborate, it's like, if I've got a new ZBrush script coming up, I can, Skype you, give you a full next 3 hours to work with your students in classrooms. I'm in Americans in Hong Kong, that's here. So this kind of workflow is really, really important for me because we don't only teach like software, or we learn industry standards. We learn the knowledge of industry people working on real projects. Right? And then V-Ray is a big thing for me because first I love V-Ray. So we're going to talk about V-Ray in a while. V-Ray is one of the most advanced CG renderers, such as Streming, V-Ray. There's a lot of renderers out there for advanced 3D. But the support for V-Ray is incredible. I met him at SIGGRAPH, and since then we've been talking a lot about having V-Ray as part of the training program. And Christoph from Bulgaria, I think, it's so amazing. He was like, okay, I know they were so far away, we're going to do a live 1-hour demo section for you in VRIC 2.0, which is not important. And according to Ivan, I'm the first one to get a better access to so I can play around with it. So the kind of support is amazing because, like, first you pay with, the coin, the computer coin. But if you are, the first few who has got the most advanced technology, at your fingertips, you can want to dive in there and then, hack it and then make it better, right? And when you're up there, you're fast way ahead. And then you can use the tool to tell someone. So all of these things, in visual effects, we do that. We use technology to tell stories, but we definitely will work with a lot of very, very smart people to help us. So we will start with some of my team people. Clement's going to show a little bit of PowerPoint presentation of what we do, what we have been doing for the last 10 weeks, I think. So you have the stage.
So we collaborated with Saw Studio on a Ruby creature design project, and this is basically we are creating a creature for production in Australia called the Rubik's Solid Monday. We first started off with a concept brief from Australia, and this is what we got. And we started thinking about how we should target this and develop this story and how we can create a feature in 3D. We don't just create a feature, but we also have film plates to take out the rope, which you can see on where the mouse is, the last rope over there. We had a few students work on this. We used After Effects, we used Nuke, so we used two of the most used softwares in the industry to try to get the rope out. We have a few clips here to show everyone what the difference is. So on the left one is the raw plate, which is what we got, and then on the right is the wire. The wire is right here. This one's a bit small, it's hard to see, but we managed to get rid of it. There's also this one, it's a bit better. So as you can see, the wire is completely gone from the face. We had some trouble with this, but then we powered through and we figured out how to do it, because the C and the movement of the person is really hard to get rid of the rope, just like that.
And this project is really amazing because one of the things I believe in the classroom is project-based learning. So instead of going there and showing you how to take the button, you actually have real-world plays and projects that you can work with, and you learn from there. Project-based learning, to me, from my experience, works better in a way because you don't only know how to work the program, but you know how to work as a team player. So that's very, very important because we work in a very, very fast-paced environment. We have, 10 students in a classroom doing different things, and then all that in real time. So instead of waiting 3 weeks to pass the subjects or 3 weeks to deliver content, every day there's a deadline. In fact, every day there's a lot of deadlines. And the pressure is there. So once, after many, many weeks, you kind of get used to the environment, you become production ready. You become a nice person. You can work with each other. You won't, throw your keyboards around. So that's very, very important for me because relationship with your teammates is critical, right? It's nothing big more than that. So this one, Trevor can talk more about that, but this one is done by Damien, right? So the little shy Damien there, my favorite, really quiet but super talented too. You want to show that, please? These are really hard shots to do. You have to remove the wires from the freaking waves. And the timeline that we use to do this is, I think Damien did it in what, a day or so?
Yeah, one or two nights.
Yeah, but 1 or 2 nights. On top of the projects in school, with other classes, so they really work really, really hard. And for me, it's really inspiring. So, I tend to work a lot with them too, to supervise them. But all these work that you see, these are done by students. Yeah, these are not like professors doing for you and you pick it up. These are real-world examples of what these kind of projects can empower not just teachers but students as well.
So After we worked with this film plate, we had to do the creature design concept. And then we have very talented artists working on this. We have Dana and Ivan and a few others who also collaborated on to this creature design project. Here are some initial designs that we have for the creature. These are done by Dana. Some are by Ivan.
And also, like, the way we sort of do the production is, a lot of people think visual effects is all about, just make things pretty. For me, it's very important that you also understand concept design. You understand storytelling, which is very, very important, and how you can develop, characters that actually has got emotions. And for us to do even the creature itself, we got Nobita. Where's Nobita? So again, very, very shy. All the very good artists are really shy. They tend to hide a lot. So my job is to like bring it out there for you guys to see. And Novi did the sculpture, the middle one. You want to talk more about that? Come on in. So time to be rock star. Come on. So the sculpture. So we came up with few designs, and we said, hey Novi, can you do some sculpture for us? And in what, 3 days or 4 days, she did amazing sculpts that you're seeing right here. The middle one, right? That's like 4 days. I'm like, oh my god, like what the hell? So it really inspires not just me, but the whole team. Is like, oh my god, look at this, cute little girl, with this gentle fingers to do amazing stuff like that. And it actually propels visual effects people to say, you know what, guys, we're using big computers with big CPUs. We can't even like do it in like a couple hours. So the thing of collaboration is not just putting good things out there, or concept design is the synergy between the teammates. And I really encourage you, like, because the thing about majors is this, like, I've got visual effect majors and animation majors, and for sometimes the thing is you're actually segregating like departments. For me, it's all about storytelling is about all departments. So it doesn't matter if you're motion media or animation or visual effects, or as one per people, but one team of people, and that's very, very important for me. So this project will actually go from painting majors. I have to like go up to the 5th floor and like hunt her down, and then I went to production. I went to like animation departments, motion media. So I was hunting down a lot of talents to work on this project. And that the reason why I'm doing again is to show that collaboration means a lot in terms of student learning, also in terms of like how we can teach in a very collaborative environment. Because I learned a lot from these people too. I learned so much, and it empowers me to create new curriculum to teach too. So it really is empowering.
So for this creature, we don't just create a creature from scratch. We also did anatomy studies and to get all the bone structure, all the muscles. So we actually did everything from the very bottom up. And this is what professional standards in the industry, if that's what they do, to get all the muscle definition, to get all the movements correct. And so this is just a drawing. Here's the bone sculpt. This is done by Dana. She spent a lot of time just studying anatomy. And when I got the file from her, you have every single one of these bones were individual objects. And then each one was labeled perfectly. And you can see there's lots of bones, and it's not that simple. She actually had like metacarpal, and
the animator saw this break, they were horrified.
So right here we have the actual bone structure in.
Anyone uses ZBrush right here? Like you're good, then you use ZBrush for one of you. I thought ZBrush everybody should use. So I introduced ZBrush to the visual effects program. I think it was three quarters ago, and now we got quite a big army of ZBrush users. They're using it a lot in conjunction with, let's say, Maya or Blender or Houdini to come up with design. Because the thing about ZBrush is the interface. I mean, a lot of you are really good. You open up Maya, it's like, what the hell? What's going on? But for ZBrush, as an artist, to be honest, if you really, if you're good in drawing, but you know nothing about technology, come to my class, give me 2 weeks to be up and running. Because ZBrush is so artist friendly. And once you get a hang of it, what you're going to do is just sculpt. And the rest about topology and animation topology, all this you can learn on the job. But ZBrush itself is a very artist-centric tool, which I love. I like Markbox from Autodesk as well. You guys use Markbox?
So after we've done the bones, we moved on to muscle sculpting. This was done by Ivan, another one of our students. He has recently transferred to Savannah. But he spent rigorous amount of time just matching and moving and having muscles perfectly along the skeleton. Actually, I'll also pull it.
I know some of you in the crowd, you're from other universities, local universities. I know you guys do amazing work too. So if you can work together on collaborative projects, that'd be cool too. So it's not just us alone, but very collaborative. The thing about me is my passion is to bring talents from New Zealand, back home, and from countries back to Hong Kong, also in China, and just have this cross multidisciplinary sort of workflow, so that the global world becomes smaller, and then you get talent plus you working with you all the time easier.
So right now we have the muscles, and then here's an exploded view of each individual parts. And you have all the abdomen here, you have all the bone, all the legs, and that's.
Can you zoom into the topology? So what you see here is very complex. Every detail counts. So if you zoom into every object, for those who haven't been exposed to topology, is when you model, you tend to model. Okay, so you model with a cube, for example. So you want to do these creatures. Every object, not just creatures, even this has got anatomy or topology, meaning the flow of lines, right? So if I model something here, edges will be around here, and then you flow down this way too. So if it's curved, it's different way too. But for creatures and human anatomy, it's really difficult because you not just only have got like straight lines, but you got like folds, you got shirts. So all these things you need anatomy. That's where fine arts come in. You go to fine arts school and you learn about how to draw and how to draw gestures, how things flow. Even the skin texture is got anatomy. It's when it's got topology. So the way your pores flow is got gravity as well. So if you don't know that, go look at the mirrors. The pores not just pores; it does have gravity, and depending on the shape of the nose and face too. So all these things you tend to learn on the job more. But so this again, I want to talk about mixing around. Have friends with fine arts people, have friends with photographers. Don't just stick with the group of just animator friends. Really spread out and know from a lot of different people. They will empower your work, and I promise you. So this is an example of topology. They will flow through, and it's all quad. So in ZBrush, we tend to use quad, meaning 4-sided vertices, so that when we for one thing, ZBrush loves quad models. But when we do like UV match, when we want to map it up, when we do skin match in Maya, it tends to help us a lot. When you do rendering, in V-Ray, we tested with a very clean topology like this. It does speed up the time by 30%. So there's a lot of, these are little details that we take into account because it will affect the whole pipeline, right?
So after the muscles, we did the skin. This was what is going to be shown onto the screen, and that's what you see in movies. It's actually just the very surface of the creature. Here we have what Gabe was talking about, topology. It's basically when you model something, you have to have the flow of the model match with the actual skin. So let's say if I have a joint area, which when I give it to an animator, there'll be lots of movements. So this so-called skin will move along as the creature is being moved around. So we will add more topology, as in those stripes. We'll add more of them so that if the creature is moved, the skin wouldn't rip, because it will rip if you don't have a good topology. Also, if you have too much topology at one area, it will just take so much time to render, and it will wear out your computer very quickly. And in production, you want to push things as fast as possible out. And what we have is normally different subdivisions of polygons. So these little squares are always evenly spread out. Here's an example of bad topology. All these like weird wavy lines, and that's not what we're trying to get. We're trying to get a clean topology.
So this is the thing, a lot of students ask me, so how do you know what's good topology? How do you know what is bad topology? Because you may be very experienced, but if you get a creature design that's really strange, how do you tell? Because you can reference, it's not about a textbook and copy what you see. So a lot of times it takes practice, it takes tests too. You have to give your base rig or base model, maybe to an animator, maybe to a texture artist, and they give you feedback. So this kind of collaborative environment is very important because you would stick to your image down the path, right? But the basic rule is to respect, say, the master flow, for example, the flow of lines, for example. And if I'm stuck, right, often I get stuck, I'll go to the finance department and see what they're doing. When they sculpt, how do they sculpt? How does it flow? Things like that. So this thing kind of inspire me, right?
So this is an example of a redone skin. As you can see, the squares are evenly spread out. There's a center line down the creature, and everything is quite symmetrical. And this is how we normally work with any type of creature. You'll always have it in a standard position. Let's say the creature has its mouth open. We'll widen it till its furthest point of movement, so that when we make the creature and when we give it to an animator, that they can close it and make sure that there's nothing wrong with it. That's why communication between different departments is really important. So when we work on a creature like this, it's not just a collaboration of your own department. It's also you have to talk to other departments to get a quality file or object for them to work with, or else they'll just throw it back to you, and then it will just go nowhere. So this is the basic topology of a creature. This is what we'll give to animators to make the movements. So this is the most basic form. And then we'll further on in the pipeline, we would actually, they will either give it back to us, or we will work simultaneously. So we don't just have the skin. Here we also, in the corners, you see little claws. Those are actually separate objects as well. Also, the teeth were made separately.
Reverse this also. Okay.
Well, I wanted to show you the difference. So when we move into the creature's head, you can see that the basic form doesn't have much. You can see nice teeth, which is done by, and the eyes actually in here.
One of the hardest part is you just don't have a pair of eyes. You got circular eyes, and then we have to connect it with the cheekbones and then back to ears and stuff. This is very hard for a lot of new beginners. But then there are a lot of tools in ZBrush that allow you to just draw the topology, right? So again, this technology behind there that help artists to reach the goal. So it's important that we work with software developers and with good artists too. Right?
So I'm going to increase the detail of the creature. When I increase it, then the computer will generate more and more of these squares and quads, because then that way we can add detail into the creature. So when you see like movie posters and you see like Avatar or Planet of the Apes, if you look at the poster, you can see pores and everything. And this comes from a detailed scout. And it all starts with the topology, because if you get the topology wrong, you can't work on this. So if I zoom in all the way down, you can start seeing tiny little pores here. And it's just like skin. And that's what you want to end up having. So that when you output it into a movie, that you will be able to see all these blemishes and all these things. To make this really fast, we will actually create a UV map. And it's basically, if you imagine a cube and you flatten the cube, it's like there's 6 sides. It's exactly what we do with creatures, and then that's what we in the industry call UV maps. These are the skins of the creature, and what we basically save all these details of the creature, so that when we wrap it around the very first version I showed you with the bigger squares, that we can render and make this really fast down the pipeline, so that we don't waste any money on having to render and use really expensive computers. So these are the textures that our whole department, everyone, Lucas, Annie worked on this the most, and this is their archive of like textures. These are basically what sculptors and texture artists would use to create the details in the skins that you see. The funny thing is, you don't really need the actual object. Let's say I have skin pores and I want to add skin pores onto the skull. Depending on what you have, I've been using stone and granite from right outside SCAD. And that creates pore-like features that you would never know if you haven't really actually used it before. So these are the textures that we have collected and that we have been using. Now I'm going to move on to animation. This is done by Arturo, our best animator and the fastest Maya sculptor and object creator ever. So here's a demo of what he created for us. Basically, the creature moves. So it's really interesting for us to see the creature actually come alive. Instead of just seeing a physical version of it, we actually see it moving. That's something that it's really hard to visualize if you're just working on it day and night. And then suddenly one day you give it to someone else and they make it come alive. That's like the most rewarding thing.
And novice sculpture help a lot in the whole pipeline, because sometimes we're stuck, right? And we just refer back to our sculptures. And then, just go back, track and say, you know what, maybe we have to adjust the bones, maybe the skin. And these are all test animation. These are done to make sure that before we move on into more expensive animation pipeline, meaning we're using a real face mesh, we have to make sure that all the skeletons work, muscles work. So there's a lot of behind the scenes work, you know what I'm saying? So it's not just having a nice model and make it move. There's a lot of test and R&D involved. So that if you're going to render down the pipe, it's not going to break, right? Because if you break, then you go backtrack. And if you go backtrack, you're going to lose money, lose time, and no one's going to be happy. So you'd rather have more time to R&D than to rush it and then make more mistakes. So that's something that everybody, I think, should learn from there.
So here's an example of the Maya model that we have. These are all movable. When you give it to an animation artist, they will move. They will create bones for the creature, and they'll also create all these things so that when you move it, when you move one point, you'll be able to see the whole arm move. So here's an example. The joints will move, and everything's controllable by us. this is very important because when we need to have these creatures posed in a certain position, when we need it to give it to the client just as a sample, this is what we have initially, and this is what we create first. So everything here is movable.
And by the way, this project is not done by like all senior projects from all senior students. A lot of this work get done by students like in their second year, beginning artists. So so if you look at it, the amount of work and the amount of talent they have in doing these projects, I mean, imagine the next year and so when they do their final projects, we literally can come up with a group team of people to make actual visual films, right? So the training itself is really actually to build up into a bigger picture, into getting a team of hardcore visual effects people, animators, sculptors, and say, you know what, why don't we do a movie ourselves? Why not? We have the talents, right? So, and including technologists, people who can hack systems, people who can do render farm, people who can, really very smart in programming, to come together and say, you know what, maybe ZBrush has got a problem, maybe mine has got a problem. Why don't we do something else and fix it again, right? So this collaboration, for me, is so important.
So it's really fun working with this. It's nice because it's every, very good pet which listens to you all the time, no matter what you do. You don't have to. So after having the bone structure and everything, we will give it to Arturo to do the skin. So this is what we actually use in the movie. So when he poses it in the movie and starts making it move, we will have the creature in this format, and then we will put it on to the actual footage. We're not at that stage yet, but we're very close to it. And that's about it for the creatures project so far. Right now, I'm gonna pass it on to Damien. He's gonna show you a little bit more of what he has done in this tool and what he's done for the creature project, especially rotoing and nuke, which is something we use in the industry the most.
So while let Damien set it up, where's Chris? Huh? Oh, yeah. All right, so Chris, my friend from New Zealand, our special guest today from Weather Digital. So he'll say more about his work, but I've known Chris for a long time, and getting him here is really, really hard. Few things, very expensive, and he's also working on Dawn of the Apes, which is due in May. So have you guys watched Rise of the Planet of the Apes? So the second one, which is due in May, he'll talk more about that. So one of my dreams is to not just to work within the school itself, but to hire to get professionals like Chris to come in here and really share the knowledge with us. He goes back, and then we can continue with the knowledge and run. And then if you got any problems or any issues, we can Skype and ask questions. So again, relationship. So important. So yeah, I'll let Damien do the thing. Damien's gonna be graduating in the next 7 weeks. So he's my senior student. Gonna go in the real world. So we're gonna talk a little bit about his work.
I spent 2 quarters in Savannah, so learning different programs in the visual effects program. So Houdini and RenderMan are taught as basic programs for us to learn. Gabe didn't know how to teach Houdini and RenderMan, so I go to Savannah to experience all of these professors. So here's what I learned from Houdini. So Houdini is a procedural modeling and animation program. It has advantages above Maya, which means that it can, being procedural, you can adjust certain values. So the model can be, you can adjust certain parameters in the model. So you can adjust how long it could be, how tall it could be, how many sections there are, and it is very good at duplicating models and making them vary in different ways, like the angle, how tall, how small it is. And it is also good at doing animation. In this case, I had to use a lot of trigonometry to solve how the sticks and rods will align with each other and animate together so that they would move in one motion. And with the render man, this is a look dev exercise. We learn how to render in render man, how to render fur, depth of field, motion blur. There's a lot of challenges involved in rendering. Sometimes you can have problems with rendering fur. It can turn out blocky, and you have to find solutions to that. So there's a lot of technical aspects to visual effects. In this project, we had to, using code, render a teapot. This was all done outside of Maya using a text editor and then sent to the external renderer. There's also shader programming involved. So the first exercise we were given to do in RenderMan shading language, the code that you have to write to generate these patterns, was to generate these simple patterns such as a square, a circle, and there's a lot of code involved to generate these. You can also generate a Mandelbrot. Afterwards, we learned how to animate these. There's a lot of mathematical randomization involved in this one. So I'm more of a technical guy than an artistic guy. So I don't know as much ZBrush as people here since I spent 2 quarters in Savannah.
She's not really my friend, so.
I still came back. This is more look dev, so I try to recreate a cupcake. And also, this is a shader programming assignment where I try to recreate this spherical circular pattern and apply it onto actual objects and then render it with correct lighting. My most recent project is to recreate a temple with a harp in it using the skills I gained earlier in shader programming. So this one is the shader for the floor, and this one is a shader for the roof with the bumps and displacements. So the offsets in displacement are put onto the floor and ceiling. I'll show the animation. There you go. There's a lot of problems involved in rendering this, and I solved a lot of the problems, but as you can see, there's still a lot of problems left to be solved, like the flickering and the volumetric lighting. There are a lot of light you just recreate the scene